ends up on the recording. So last time, or I guess it was 2 times ago, because last time we did the applications, I taught you the sine and cosine graphs, and you just learned a new shape. It was a wave. Now we're going to do the secant and cosecant graphs, and it's just going to be a new shape. But the process of how you do the problem is actually not any different. So it's almost like not new. You're just doing a different shape of a graph. All right. But what we want to do is draw this on here. I have mine on a sticky note, so I can just pull it out because I do this all day long. But just draw that at the top of your paper. And we're going to do the exact same thing we did with sine and cosine. This one just says cosecant. How do you get your cosecant values? You're going to flip what? You know, it's like, is it X or is it Y? You're going to flip Y. So we're going to go around our circle. We're going to get all the Y values and we're going to flip them. Okay. So starting at 0 pi, that's right here. What is your Y value? 0. You can't flip 0. You can't divide by 0. So what are we going to put? Undefined. There we go. And what does that mean is going to be in the graph? Once I draw it, there will be an asymptote. Okay. Now we're up here at pi over 2. Your Y value is 1. If you flip 1, it is still 1. 1 over 1 is 1. So that's still going to be 1. All right, here's pi. Again, we have 0 for our Y value. So undefined. And if you're like, wait, there's going to be another asymptote. Yeah, there's going to be an infinite number of them because this is cyclic. 3 pi over 2. What do we get? -1. If you flip -1, it's still -1. 1 over 1 is 1. It's just negative. And then 2 pi puts you back where you started, the undefined. Now we're going to go around the circle backwards. Same thing, except we're going the other way. Negative pi over 2 is going to be down here at the bottom. That'll be -1. And then undefined. And then +1. And then undefined. So we're going to take that information and put it on our graph. And so we have an asymptote at 0. And then pi over 2, we get a point at 1. And then you have another asymptote. And then it's -1. And then you have another asymptote. And that's going to be the pattern. And if you're like, wait, what on earth is this going to look like? Just hold on. I'm going to show you, obviously. All right. When you go the other way, we had -1. And then another asymptote, and then +1, and then another asymptote. And again, it keeps going forever, following that pattern in both directions. So you could keep on going if you wanted to. And what this looks like is you take that starting point, it almost looks like a belly button of the graph, and it creates a U shape, and the U shapes always face away from the x-axis. I call them smiley faces and frowny faces. They aren't technically parabolas. The word parabola is for a quadratic, and this is a cosecant function. It's not a quadratic. If you call them parabolas, though, I'll forgive you. But I call them smiley faces and frowny faces. So you're going to get an infinite number of these smiley faces and frowny faces. Cool, huh? The neat graph. Neat, guys, right? That's your new shape. Smiley faces and frowny faces. All right. Now here's what I want to bring up. And don't draw this on your paper. Okay, I'm just going to put this on mine so you can see it. If I were to connect those points like this, what do I get the graph of? Which one is it, though? It starts at the origin, so this is the graph of sine. Cosecant and sine are reciprocals. It's like you took the sine graph and turned it inside out. Get what I'm saying there? Like you took that wave and just flipped it inside out is what happened, okay? So I just want to, draw your attention to a few things. We're going to do domain and range. You're not going to like domain, but I'll get you through it. Let's do the range first, because domain can be difficult. Range, you're going to sweep downwards to upwards. It's been a while since we did this. It will be -infinity up until -1 with a bracket or parenthesis. Bracket, there's actually a point there. So it'll be -infinity up to -1. Good. Bracket. Union, because you have this place where it's missing. See, I told you not to draw this on yours, so it wouldn't mess you up. This is like no man's land in the middle here. And then it picks back up at 1 with a bracket to infinity. And usually I will just wait until I get the graph to answer that because it's easiest if you have a visual to follow. Domain you're not going to like very much, okay? The way we write it is, because you have an infinite number of these asymptotes that you have to exclude. It's all reals except for where the asymptotes are, okay? So it's everything except those. So we write all x not equal to, like the no parking sign, like the equal with the line through. It's everything except, and then you're like, how do we leave them all out? There's an infinite number of them. You start with the first one, and it's like, well, which one's the first one? It's either 0 if it's on 0, or the first positive one. That's the first one. So this one happens to be on 0 pi. So 0 pi plus however often they occur, because it's cyclic. So how often is there another asymptote? We have 0 pi, and then 1 pi, and then 2 pi, and then be another one at 3 pi. So they're happening every 1 pi. So we write plus pi n. The n takes care of the fact that there's an infinite number of them. N could be any number. So it's where you started plus however often they're happening. I have a couple more things to say. If you flip this over, go. I heard some of you flip it. All right, it is discontinuous. Do you remember on sine and cosine how we wrote continuous? And I was like, I'm bringing this up because some of the other ones aren't. This is a compare and contrast thing. I'm going to give you a sheet like this for all the parent functions so you can get used to the shape of them. This is an odd function, just like sine. If sine was odd, cosecant is also going to be odd. It means there's symmetry to the origin. If you look at this U shape, it goes down here, like there's symmetry across the origin. What was the other thing I was going to say? Oh, period is still 2 pi once around the unit circle. So once around the unit circle is 1 full cycle. Oh, and then this is important. Maybe put some stars next to this. Your amplitude is none. The reason it's none is that word is by definition about a wave. An amplitude goes with a wave. So if your shape isn't a wave, you don't have one. And you can't say 0 because 0 is a value. You have to actually say none. Do you get this? Because it should be an automatic answer, but I don't want you to miss it. Your amplitude is going to be none if it isn't sine or cosine. All right, so let's try this one. It's going to be the exact same thing, except when we go around our circle, since it says secant, how do we get the values? We're going to flip x, and it's going to look remarkably similar. All right, so what's our first one? We're starting at the beginning here. 1. And then undefined. I'm going to speed this up a little because it's going to be the same as what I kind of took my time on the other one. This one we can get through a little faster. And then the next one's going to be -1, and then undefined, and then +1. So when you go backwards, this is going to be undefined, -1, undefined, +1. So take those pieces of information, some of them are points and some of them are asymptotes, and go ahead and put them on the grid. We're going to start at 0, 1. So we'll start right there. And then you can just keep the pattern going. You have asymptote and then -1, and then asymptote and then +1, and then asymptote. Like you can just keep the pattern going, hopefully, at that point. And then you get an infinite number of these smiley faces and frowny faces. And I want to state the same stuff that we did on the other paper for this one. Again, what I'm trying to do is give you like a sheet that you can look back at for all the parent functions. So we're going to do domain and range. Oh, and I didn't draw it on this one, but do you guys get that if I connected these in the middle, like this wave, what graph would we get? It would be cosine, and it's like we turned cosine inside out. Cosine and secant are reciprocals. That's what's going on there. All right, so let's do range first because it's a little easier. If you sweep downwards to upwards, it'll be negative infinity up to -1, union, and then 1 to infinity. So you're missing that middle section. And then the domain is a little annoying to write, all right? It's everything except the asymptotes. So it's all x except, so all x not equal to, like the no parking sign. And you take the first one. Now the first one is either 0 if it is, but this one's not 0, or the first positive one. So where's the first positive? Pi/2 is the first one. Plus, however often they're occurring. So we have one at pi/2 and 3 pi/2, and then the next one would be 5 pi/2. So it's still every pi that they're occurring. So every pi n. Excuse me. All right, it is very discontinuous. And it is an even function. Cosine was even, so secant is also going to be even. They go together. What's the period? 2 pi. Once around the unit circle is 1 full cycle, unless it gets stretched or shrunk, which we're going to look at in a second. And then amplitude is only for a wave. Since this isn't a wave, you're going to say none. And you can't put 0, because again, 0 is a value representing nothing, which is different from there isn't an answer. So you have to put none. Or you could put NA, or you could write something silly that indicates there isn't one. I don't care. But like in some way, you have to indicate that there isn't. All right, so let's go to the examples paper. I think I put 2 that are cosecant and 2 that are secant. We'll do 1 of each. And then I'll fill out the others and post them so that you have the answers too. But we'll do 1 of each, okay? Domain and range, you're going to have to wait on for this. The thing that makes me nervous about that is you have to remember to go back and answer it, okay? So just don't forget, all right? But we will have to wait until we get a picture to do that. Amplitude, none. It's an automatic answer, but you have to remember to put that. Now, all the rest of this, you're going to get the same way. The period would be 2 pi over absolute value of which number in the equation? 2. It is the exact same thing you did for sine or cosine, exact same thing you did on your quiz. Like the process didn't change. So what is that going to reduce down to? Pi. So you took it and you squished it this way. It was 2 pi. Now it's just pi. Like you took it and compressed it. Phase shift is your left or right. Do you see anything added or subtracted in here? No, so you can say 0 or none. Vertical translation is up or down. You can write down DOWN3 or just -3. And then this is the same as well. You're going to start with the phase shift, which this one's 0, so that's nice. And then you add the period because you want to go 1 cycle. So nothing plus pi is pi. And then you have to break down the fractions, which I looked over your quiz, like I started grading them. You guys nailed that. That's the hard part. You guys got it. Halfway between these. Half a pi. See, you're not going to be able to act like you can't do it now because I know you can. The one on the quiz was kind of hard and you guys got it. All right, halfway between these, pi/4. And then basically you can count. That's 1/4. This is 2/4. The next one would be 3/4. Cool. But if you can't get that, it really doesn't matter. I'm going to cover it up anyway. We're going to go around our circle. This one says cosecant. So how do you get your cosecant values? You flip y. Good. You're going to flip y and then subtract 3. Now, if you get an undefined, you can't do an asymptote -3. It's just undefined. Okay. But you're going to get your values, subtract 3. So what is your first y value? 0. So we're going to put, oh, and just to reinforce, you always start at the beginning. Okay. So your first one is undefined. Then up at the top, it's 1. If you flip 1, it's still 1. -3 will be -2. And then what's the next one going to be? Undefined. And then you're down here at the bottom, it's -1. If you flip that, it's still -1. -3 would be -4, and then undefined. And we're going to take that and put that on the grid here. Now you want to count by fourths. So here's what I would do. Go to the 4th tick mark and call it pi. And then you can go to the 8th tick mark and call it 2 pi. And now you know that each of them is a fourth without going 1/4, 2/4, 3/4, 4. Which you can do if you want, but I think that's a little annoying. All right, and then you want to graph at least 2 cycles. That means 2 smiley faces and 2 frowny faces. You want 2 of each, all right? So at 0, we have an asymptote. And then we're at -2. And then another asymptote. And then -4. Oh, this is going to go off the grid a little bit. That's okay. And then another asymptote. And then you need to keep that pattern going. So where's the next point going to be? We did -2 asymptote, -4 asymptote, and then the next one's going to be -2 asymptote, and then -4 asymptote. So you want 2 smiley faces and 2 frowny faces. And you should always have that like no man's land in between them. Like there should always be a blank space. And you can imagine the sine wave in between it. But they should face away from each other. Smiley faces, frowny faces. Now you just can't forget to go back and answer the domain and range. I guess you can forget, but then I'll have to mark it wrong. So try not to do that. I would do range first. I think it's easier. This would be -infinity up to where? -4, good. Because you can kind of just look at it at that point. And then union, -2 to infinity. Cool. And then the domain is the one annoying part. It's everything except for where the asymptotes are. And the problem is there's an infinite number of them. So you take the first one and it's either 0 or the first positive one. So where's this first one? 0, which is nice. 0 pi plus however often they occur. So you can either look at the graph or look at the table. We have one at 0 pi and then pi/2 and then a whole pi. So how often are they happening? Every pi/2, and then you just put an n with that to show that it's forever. It's every pi/2. You get another one of those. So flip over and we'll just do one on the back. Oh, I'm sorry. Go ahead. We'll do the last one because you have to factor that one and that can be tricky. So we'll do 4. Do you see how there's a 3 right here? You have to factor that 3 out of this before you can figure out what the phase shift is. So let's rewrite this equation and kind of just leave a blank there. You have to factor out that coefficient. So it's GCF, it's greatest common factor, which is 3. So you're going to put 3, and then in the parentheses, it's going to be what's left once you divided out a 3. Which would be x plus, now if you take pi and divide by 3, it would be pi/3. And the way you can check your work is, if you were to distribute the 3 back through there, you would get what you started with. Is everyone together here? You have to do that in order to see what the phase shift is. You won't get your phase shift correct if you don't do that. Now I'm going to skip domain and range, wait till you get the picture. What is amplitude? None, good. It's only for sine and cosine. That vocabulary word is only about a wave. All right, period would be 2 pi over absolute value of 3, which would just be 2 pi/3. So again, we compressed it to a third of what it was before. So your phase shift, this is why we factored. Did it go left or right? It's kind of backwards. Went left, pi/3. And so you can put -pi/3, or you can actually write left pi/3. And then what's your vertical translation? I make all of, I'm not sure if I should put this in the recording, but I will. I make all of these 10 points each. How many points did we just get without even really doing the problem? Like you're almost halfway without even It's graded in a very forgiving way, I guess is what I'm trying to say. All right, what's going to go right here? Where do we start? Phase shift, so negative pi over 3. And if you're already nervous, calm down. It's not going to be that bad. You're going to, I know, because it's a fraction and it's negative, so like double whammy. You're going to add the period because you want to go one full cycle. So forget about the pi for a second. That throws people off. Negative a third plus 2/3 would be positive a third. And you guys in my class that said W, that's a huge W because what's halfway between negative a third and positive? That was you guys, wasn't it? 0 is halfway in between. Now we have to break that down. Thirds break down into 6. So this will be negative pi over 6, positive pi over 6. So sometimes it looks scary at first, but you kind of have to trust the process and then you'll get through it. All right, so we are going to go around our unit circle, get all our values and subtract 1. Unless it's an asymptote, you can't do an asymptote minus 1. All right, now this is secant. So how are we going to get our values? We're going to take x and flip it. Okay, so what's your first x? 1. Flip that 1, but you have to minus 1. So 1 minus 1, 0. And then at the top, it's 0, which would be every other one is going to be undefined. All right, the next one's negative 1. If you flip that, it's negative 1, but then you have to subtract 1. So negative 2. And then I'm going to get rid of this. You kind of don't need it at that point. The next thing is undefined, 0. Like, yes, once you get it started, just keep going. Now you need to label these by 6. So just go to the 6th one and call it pi. And you can go to the negative 6th one and call it negative pi. And then you know they're each a 6th, and you don't have to label them all individually. And then we're just going to take this information and put it on the grid. So negative a third, that's negative how many 6? Good, perfect. You guys are good with fractions. Negative 2/6. So that's going to be this tick mark right here. And we'll start at 0. And then an asymptote. And then negative 2. And then another asymptote. And you want to do at least 2 smiley faces and 2 frowny faces. And you can go whatever direction you want. And then just don't forget to go back and answer the domain and range. You will be bummed out on your test if you accidentally leave that blank. Like, just remember to go back and answer it. I get why that happens. And I try to start looking through the tests as you turn them in and give them back to people that forgot, but I'm not perfect and I can't get to everybody. So try to remember. All right, so your range would be negative infinity up to what? You're going to sweep downwards to upwards. Negative 2, bracket, union, and then good, 0 to infinity. Again, it's like you turned the cosine graph inside out. You can imagine a wave in between them. And then domain, I get that that's the annoying part. It's all x except, like you want everything except where the asymptotes are. So you take the first one and it's either 0 or the first positive one. So this one's not 0. Where's our first positive one here? Yeah, pi over 6. Plus, however often they're happening. These are happening every 2 tick marks. Do you see how it's every 2 tick marks? So every, good, perfect. So plus 2 pi over 6. Oh, actually, I could reduce that though. What would that? Pi over 3n. I would not mark 2 pi over 6 wrong though, for heaven's sake, if you got the right answer. I don't mark reducing fractions wrong in this, you know, I mean, unless it's like the period, I need you to reduce that. But like on here, if you get the right fractions, I'm like so happy that it's all good.